Hi there. In this video, I'm going to tell you about Snowflake Streams and Tasks, which is just one module in my Snowflake training course, Mastering Snowflake Fundamentals, Insights and Best Practices. In this module, we'll talk about streams and tasks, which is one of the ways of loading data and processing it into Snowflake. So let's start with a task. A task is really just a schedule. It's internal to Snowflake, and a task can be set up to execute a single SQL statement or a Snowflake script or call a stored procedure. And it's used, for example, to do ETL loading or to summarize results, anything you'd want to do on a regular schedule. So you create a task using the create task statement, give it a schedule, call a stored procedure, and because every task is initially created suspended, you need to resume the task, but you can always suspend it. And that means every hour in this case, this task will be restarted and it will call that stored procedure. In terms of scheduling the task, the root task or the first task in the sequence must be scheduled. And you've got a couple of options. You can give it just simple scheduling like 60 minutes, or you can have quite flexible scheduling using the cron definition, which gives you flexibility of day of the week and years and times. Tasks can also be dependent on other tasks. The diagram on the right describes what the sequence is on the left. So what you have is a load sales task that runs every 60 minutes. The next task, load trans, will load after the load sales process is finished. And then likewise, the load reference will also load once the data's finished. And you can see here visually what the dependency is. A task can have a virtual warehouse, which indicates which virtual warehouse to execute the task upon. And finally, you can also leave the warehouse definition off, in which case it will use Snowflake serverless compute in order to process the data. This is charge per second billing with auto scale up and is actually now at a 10% discount against the cost of a warehouse. So it's actually quite cost effective to use serverless tasks. So let's have a look at how you would use this within, say, a batch processing for regular bulk processing, typical sort of thing you find on a data warehouse. With a batch processing, what you have is a repeating cycle. You're going to need some sort of orchestration, some sort of tool that configures when things run, checking that stuff is completed successfully, and then the next step can run. And the first step in there is going to be loading the data files into cloud storage. Once the data files are loaded, you can then use, for example, Copy or Snowpipe to load the data into a landing table within Snowflake, and then you call the ETL process. And of course, you'd probably want to load several tables at once to make sure all the dependencies are in there before you start your ETL processing. That may write intermediate or final data in the data integration area, and then you call an ETL process to actually deliver the data to the end user in a form ready for analysis. The thing about this, on every cycle in your orchestration, what you're going to do is you're going to delete the existing entries and then trigger the load of the new entries. And that's how the next cycle will process the newly arrived data. Let's see how we could implement that using streams and how streams implements change data capture to identify new or changed records. So if we look at a streaming pipeline, it's really there for continuous delivery. I'm going to use an example using Snowpipe, but equally you could use Copy. Your source system delivers the data files. Snowpipe will automatically load the data files as soon as they have arrived, and they will be appended to the table in the landing area. your ETL process will then pick up the data, process that data, and then your second ETL process will load up. The thing about this is you need to identify the newly appended rows. You also need to know when the previous entry is completed. So let's have a look at how you could do this with streams and tasks. Let's say your file has been delivered, Snowpipe has loaded it into the table. Well, a task will automatically pick up every, say, 10 minutes or every hour and trigger the ETL process, which will read from the stream. And the stream does the change data capture. So the stream picks up only the data which has been added since it was last processed. And that will be then written to the target table. So how does that work? Let's say you create a stream and you insert data into the sales table. You then create the stream on that sales table, and my stream is called sales stream in this case. So now I've got both the sales table and a stream over that. And it's once the stream is created, it's only going to show changes since the last point. So if I now select staff from sales, I see there is one row in the table. If I select from the stream, I get no rows returned. If I insert new rows into the table, 2 and 3, and I select from sales, I now see my 3 rows. If I select from the stream, I also see my rows, but I also see a couple of bits of metadata. And this is the rows since the stream was created. Remember, I'd already inserted one row, and then I created the stream and inserted the next 2 rows. And you also have this metadata down here saying what the action was and a unique identifier. So let's have a look at that in a bit more detail. If I select from the stream, what I see is the metadata action, which says whether it's an insert or a delete. And update is shown as a 2-step operation. An insert with is update as false is a normal insert. A delete where the data is update as false is a normal delete operation. And then update operations represent the logical removal of a record before and the addition of an entry afterwards. So this represents the before and the after image of the update. How do streams work? Well, let's say we created a table customer and it's got a set of columns on there. At this point, we've just got a table. We then create a stream over that table, create stream, customer stream, and we have a stream offset. This is the pointer, which is really all a stream is. It doesn't store any data. It's just an offset pointer within that table. Physically, it just adds a couple of bytes to the table itself. If I was to now select staff from the table, I will see there's no rows. If I select from the stream, I'll see there's no rows because I've not inserted anything. Let's say I now insert a set of data from a staging table and I see several micro partitions. Notice my stream pointer has not changed. Now, if I query the data, I can see the data directly from the table. And if I query the stream, I see the existing data and I also see the action. And I see the remainder of the metadata. I'm only showing the action that shows that rows have been inserted. So let's say I process that data. So I now insert into a table called new customers and I select from the customer stream, but I'm only interested in the insert. You can limit this to only give the updates or the delete operations. And I can then, based upon that workhorse, I can then deal with the rows, inserts, updates, or deletes as appropriate. When I actually commit, it will actually automatically move the stream pointer forwards. And that indicates that we've processed these records. So now we are using the stream to give us the change data capture. Give me the records that have been added since the last time I processed the stream. So now if I query the table, I still see the data in there. That's not changed. But if I query the stream, because I've consumed all the entries and the offset is moved to the end, there are no results available from the stream. So in conclusion, the stream offset is used to track changes, insert, updates, and deletes. And when we've processed the data from the stream and committed, the pointer, the stream offset, is moved, and it uses time travel to track the changes, the inserts, the updates, and the deletes. And this is automatically extended on the table up to 14 days. So you've got 14 days during which you can process the data from the stream. Now we'll go into a hands-on lab so you can get some hands-on experiences with streams, and I'll see you in the next module. As I said, this module is just one small part of an entire Snowflake training course by me, John Ryan, at Analytics Today. It covers a huge range of subjects, and I'm happy to deliver this either as pre-recorded self-paced training or as a live instructor over 3 days. So if you or your company are interested in some of the best Snowflake training available, just like this video, you need to visit my website, and don't forget to like or subscribe to this video and get notified of new material. That's www.analyticstoday. Let's talk soon. Thanks.